from Launch Complex 39A at Kennedy Space Center. SpaceX now has 3 operational launch sites: Launch Complex 39A at Kennedy, Space Launch Complex 4 at Vandenberg, and the pad of today's launch, Space Launch Complex 40 at Cape Canaveral Air Force Stations. More launch sites allows SpaceX to launch more frequently, which is a key step in achieving our goal to full and rapid reusability on our way to Mars. The unique markings that you see on the rocket following re-entry are reflective of both the difference in temperature of the rocket's propellants and the proximity to the engines at the base of the first stage. We carry both liquid oxygen and rocket-grade kerosene, also called RP1, on the rocket, but the liquid oxygen is super chilled, which changes how the soot and heat from the engines interacts with the surface of the rocket. Where the stage is colder, soot isn't able to stick as well. Falcon 9 is a 2-stage rocket, which means it has 1 stage to get out of the atmosphere and a 2nd stage to get the satellite up to orbital speeds. The first stage has 9 Merlin engines, which is why we call it Falcon 9, and is about 2/3 the overall height of the rocket. And the main job of that first stage is to get us out of the densest portion of Earth's atmosphere, and it will accelerate GovSat 1 as well as the 2nd stage to the edge of space at a few thousand miles per hour. At that point, the 1st and 2nd stage will separate. The 2nd stage will continue accelerating GovSat 1 up to speeds of about 17,000 miles per hour. In today's mission, we will not be recovering the 1st stage. Let's check in on Falcon 9. The 1st stage helium load and the 2nd stage helium load began early this morning. Those are largely complete. The pad was cleared about 8 hours ago. Propellant loading began just over an hour ago, and RP1 is now at about 99% full in both the 1st and 2nd stages. Liquid oxygen load began 30 minutes ago. And we are looking at about 95% complete in the 1st stage and 90% complete in the 2nd stage. The range is currently a go, as well as the payload, which transitioned to internal power about 30 minutes ago. Weather-wise, we've been sending balloons up to gauge the upper altitude winds, which are looking good. We've been keeping an eye on the thickness and height of some stratocumulus clouds. You can see them on the screen there. We don't want those clouds to be high enough or cold enough to form ice crystals, but those aren't a concern for launch. Engine chill began about 4 minutes ago. It's important to get the engines to the same temperature as the propellants so that the liquid oxygen does not suddenly turn into a gas upon contact with the much warmer plumbing, among other things. We've got several members of the GovSat 1 team in Florida to watch today's launch of GovSat 1. In particular, we would like to extend a warm welcome to the Prime Minister and Deputy Prime Minister of Luxembourg, as well as their Royal Highnesses, the Prince and Princess of Luxembourg, all of whom are watching today's launch in person from Florida. Designed exclusively to address governmental and institutional security user needs, GovSat 1 is the first satellite of GovSat, which is a public-private partnership between the government of Luxembourg and world-leading satellite operator SES. The public-private partnership is unique in that it allows governments to take advantage of the lower costs associated with commercial satellites while still meeting governmental security needs.
GovSat is a brand operated by LuxGovSat SA, a public-private joint venture company between the Luxembourg government and SES, the world-leading satellite operator. Our mission is to provide secure, reliable, and accessible governmental satellite communication services to address the demand resulting from defense and institutional security applications. GovSat-1 will be a multi-mission satellite, which will use X-band and military Ka-band transponders with wide beams, as well as with high-powered and fully steerable mission beams. As a geosatellite, GovSat-1 will provide superior, accurate, real-time information wherever it is required. Over Europe, Africa, Middle East, and substantial maritime coverage over the Mediterranean and Baltic Seas, as well as over the Atlantic and Indian Oceans.
We are coming up on T-minus 4 minutes before launch. We are tracking no issues at the moment. We've just finished up loading up the helium that's pressurizing the first and second stages, and we're in the very final stages of liquid oxygen and RP1 loading. By loading those propellants so close to launch, we can keep them very cold. And being denser, that means we can load a little bit more of each of those propellants onto the vehicle. We're also performing some final communications checks with the full Falcon 9, and also testing the thrust vector control system, which basically wiggles the engines to make sure that those are properly able to steer Falcon 9 during ascent. We are preparing for Falcon 9 to take full control of the rest of launch, and the spacecraft is still a go for launch. At this point, we're just coming up on about T-minus 3 minutes before launch. Let's listen in to the last few minutes of terminal count.
Stage 1 LOX load is closed out. Stage 2 LOX load is closed out.
Yep.
Vehicles and self-align.
AFTS is ready for launch.
Falcon 9 is in the startup. Launch directors go for launch.
Minus 30 seconds. Minus 15 seconds. Stand by for terminal count. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff.
Vehicle is pushing downrange.
Stage one propulsion is nominal.
Power and telemetry nominal.
And there you saw a successful liftoff of the Falcon 9. Stage 1 propulsion all looking nominal. Beautiful clear shot of Falcon 9 ascending through the Florida sky there. About to go through supersonic. You may see a sonic boom with this sort of clear sky.
Vehicle is supersonic.
Coming up shortly, we're about to enter max Q. That's the point of maximum aerodynamic pressure when the rocket is pushing hardest against the atmosphere.
Vehicle has passed through max Q.
We've successfully passed through that point. That's always a major milestone in every rocket launch.
Impact engine chill.
We've just begun chilling the second stage engine for the same reason that we chill the first stage engine, to make sure that it's ready to be at the right temperature, the same temperature as the propellant. Coming up about 30 seconds from now, we're going to have a few events in quick succession. The first stage engines are going to cut off.
Recovery vessel has AOS.
The two stages will separate, and the second stage will ignite. You can see the plumes fading away as the rocket is getting out of the atmosphere. Trajectory is still looking good, and those three events, main engine cutoff, separation, and second stage ignition, happening right now.
Maybe go.
Stage separation has confirmed.
And there you saw it. First stage successfully cut off, the two stages separated, and the second stage has begun its burn. You saw the retaining ring fall away, and that protects the MVAC Merlin vacuum engine nozzle during shipping. Again, we are not recovering the first stage on this mission, but we are about 30 seconds away from fairing deploy. The fairing protects the satellite during ascent, but it's not necessary once you get out of the atmosphere, and so we'll let it fall back to Earth to keep that propellant available to loft more satellite.
Fairing separation confirmed.
And we've got confirmation of the fairings separating. You can see one of the fairing halves in the screen behind the second stage engine there. Beautiful clear shot of second stage against the Earth background.
Acquisition of signal, Bermuda.
Trajectory for stage 2 is still nominal. This burn is going to continue for about another 4 minutes, at which point the second stage will then turn off its engine and have a coast phase for about 17 minutes. It'll be in a parking orbit at that time, and the coast phase will be preparing for the second burn, which will push the satellite into its geostationary transfer orbit. We're about T plus 5 minutes and 20 seconds at the moment. At about this time, the first stage would be on its way back to the drone ship. And it's weirder to consider that we're not actually recovering this one. SpaceX has landed, I think it's about 20 first stages at this point. And the goal is for each first stage to last tens of launches in the short term and hundreds or thousands of launches in the long term. T plus 6 minutes and 15 seconds. Trajectory still looking nominal. And that second stage burn going to continue for another 2 minutes or so.
Stage 1 AFTSS saved.
Stage 1 entry burn has started.
Stage 2 continuing along nominal trajectory.
And stage 1 entry burn shut down.
You just heard the call out that the stage 1 had its entry burn start and then shut down. While we are having a re-entry burn, we are not recovering the first stage. T plus 7 minutes and 20 seconds. Second stage propulsion and trajectory all still looking nominal, just the way we like it. And about 1 minute remaining in this first burn to get to a low altitude parking orbit for GovSat 1.
Stage 1 is transonic. LOS, Cape Canaveral, stage 1, as expected.
Stage 2 is under terminal guidance. Stage 2, AFTSS saved.
We're about 30 seconds away from the second engine cutoff event. You'll be able to see that on your screen.
Stage 1 landing burn has started. Legs have deployed.